SwiftUI animations. However, you might need a bit of experience on the basics of SwiftUI framework, like how to create views and how to lay out things, and also to how to add modifiers to it, how to change the appearance, something like the basic things you might need. And my primary intention for this session is to introduce various features in SwiftUI animations with some hands-on coding sessions, and also to give you some inspiration to get you started with the animation in your app. So I will show you a full agenda for the session today. So that's the agenda for the session today. So we will talk about why we should use animation in our apps. Then we'll talk about the different types of different ways of adding animations in SwiftUI. Then with some animation options and view transitions. Then we'll go ahead with the customizing some of the animations, and we'll learn more animation techniques from some of the advanced animation techniques. And apart from that, then we'll check, we'll see what is the alternative approach to adding animations to our app. That also we'll check here. Then we'll end up with some best practices and resources. So that's the agenda for today. There is a lot to cover. So without further ado, let me get started with that. So why animation? So animation gives an extra boost to your app. I hope everyone will agree to that. So animations are like movies. So movies are nothing but a series of images put together, perceived as a motion picture. Similarly, animation is a series of frames or state changes put together forms an animation. So with animations, you can enhance your user experience. Like we can provide an instant feedback to the user's action, and we can indicate a particular state change in the screen so that the user will be aware about it. And we can also improve the navigation effects between the screens. So these small little animations make your app stand out from other similar apps in the market. So that's the reason we should use animations in our app. So SwiftUI animations, I'll talk a little bit about UIKit and SwiftUI. UIKit is a former framework so where we have to tell the system what to do with every step-by-step instructions. So UIKit animations has to be triggered manually, but in SwiftUI, you just describe what you want, and SwiftUI figures out the details. And the SwiftUI animations are not simpler and directly tied with the state changes. When a state change, then the animation happens automatically. And it makes it easier to add animations. You just need to add an animation modifier to a view, then the magic happens. And we don't need any external libraries for animations. Everything is built in. And there are 3 different stages of animations here. Trigger, state change, and animation effect. A trigger is something like a button click or a value change, or an event like a view appears on the screen. So that will trigger the state change, and the state change will cause a property change in the view. Then the animation occurs in response to the property change in the view. So that's the different stages of animation here. There are multiple ways to add animations in the app, with implicit animations, explicit animations, and custom animations, and transitions, and so on. There are different ways you can control the animation as well, through speed, the way the animation takes place in your screen. So now let's look at the implicit animation. So implicit animations are straightforward. You just need to add animation modifier to your view, and SwiftUI automatically animates the changes to your view. So I'll show a little demo. So here I have a project. Can you all see my Xcode properly?
Yes.
Okay, right. So here we have a demo project. I have a series of views, some basic skeleton views here. to demonstrate the animations here. So let's start with the implicit animation. So let me declare a state variable here. Then have some stack. I'll put some spacers here to align the content in the center. I will create a rounded rectangle with some corner radius as and I will fill it with some color, and I'll set some frame for it, 100 by 100. So we have a rounded rectangle on the screen now, and so I'll have some animation button here to trigger the animation. So name it as animate. Some font, launch, padding around the V stack. So now we have a trigger here. This is a trigger, and this is a state change, and the third part is the animation effect that we are going to apply on this rounded rectangle. So the one that we are going to apply is offset. We're going to trigger the animation. So we are going to make a state change here. So we are going to toggle the animate here. So now when you run it, you don't see the animation because we haven't added. So we can only see the start and end state. So in order to add animation, we just need to add an animation modifier here with some default animation type, and the value is animate. So you have to specify which value here to trigger the animation. So now you can see a smooth, nice animation here. So the same animation can be done in multiple ways. For example, if I just put the position attribute here, I'm going to trigger animation. The position attribute here, 20 x is, and this would be something like 100. I'll put this would be something like 300. I'll put only 70. So now you can see the same animation with the position modifier. More to that, we can also do the same animation with a different approach. Like I'll just wrap it with a G stack. I'm going to animate with the alignment. So I'll set some frame for the G stack. I'll put some color here. We expand the view. Animate. If it is animate, then it will be traveling. No, then it will be ready. So now we can have the same animation. So there are multiple different ways you can achieve the same effect within SwiftUI. So that those are the three different ways to achieve the same animation here. So probably I'll remove this for now, and I'll keep only the offset. Yeah, keep offset animation here. So now we can modify other little modifiers here to change the animation. For example, this color. Now the color can be animated. Similarly, there are a lot of other properties like scale effect. If I want to scale it 1.5, so that's the scale effect along with color and offset. We can even go further like rotate effect. Put some, I'll rotate it for 180 degree. You can see nice little animation with all these properties. So there are multiple properties that can be animated with the same value. And also another thing to note, this value can be anything. It need not be the animate value here. For example, if I can declare another trigger here, I'll just put that trigger value here, and if I can just toggle that trigger, then you'll see the same animation here. So this trigger is just a starting point to trigger the animation on this view. Whatever happens within this view, that will all be animated. For example, suppose if you don't toggle it, if there is no change in the animate, then there will not be any animation. Similarly, if there is no trigger, then there will not be any animation, only the start and end state. So there's a trigger and the state change, and then that state change leads to the property change that will be animated with this animation modifier. So let's talk about the type of properties that can be animated. Here we have seen fill, scale effect, and rotation effect and all. Let me switch to the slide. What can be animated? So these are the properties that can be animated. So one simple rule is that anything numeric that can be animated. If it is a numeric value, then it can be animated. Even the color is also a numeric value. That's why we were able to animate the colors. Let's talk about a few other options within within this animation thing. So if you type this, there are various different animation types available here, like bouncy, ease in, ease out, and there are different types of animations available. Each will have different kinds of speed setting. So I'll go with ease in and out, and you click when you put a dot, then we'll have a further modifiers where you can delay the animation. Suppose if you want to delay the animation by 2 seconds, then when you click, then it won't start for 2 seconds. I clicked it. After 2 seconds, it will start the animation. So you can control when the animation should start here. And also we have something like repeat for a repeat count. You can repeat the animation for number of times. So each direction will be counted as one. So we have a 3 count here. So suppose if you don't want to reverse it, then you can have auto reverse parameter where you can set false, then it won't be reversed. It will be one direction. Similarly, we have repeat forever thing is there. The repeat forever is it will repeat forever. So it can stop. So those are the little additional functionalities there. And when you talk about this animation types, there are various different types are there. So for example, if I just put bouncy, you can see the effect. Can you see that? So this the shape is just going out of the frame and bounce it back. So similarly, we'll have multiple different types of things are there. So let me just pull that thing. So those are all called animation curves. Okay, so each one will have different animation curves. So if you take about a linear, then it will have a constant speed. If it is a ease in and out, then it starts slow and speeds up and ends slow. If it is ease in, then it starts slow, then stops the normal speed. Similarly for all other things. The spring animation have a different animation curve. It's all about the speed and how the animation is performed. So if you can see this repeat count, so there is a curve here, three lines here. And repeat count autocorrect of only two curves here. I have a small little demo to demonstrate that in a better manner. Sample thing, animation curve samples. So here I have put all possible animation types here, and I'm just animating it with a single click simultaneously. You can see that this will give you an overview of the animation types and how it is performed. You can even yeah, already you can even slow it down and see how it is getting performed. So that's about it. And so now we'll see about explicit animation. Explicit animations give you precise control over the timing and effects. If you want to do the animation on a specific condition, then we can use with animation function. I'll show you a little demo of that. We have some basic skeleton here. So I have a code snippet that will give me the skeleton code for this project. We have this animation, the variable and the triggers and all set up here. So what I'm going to do is I'm going to change this to a circle. I'll remove this button now for now. I'll add an overlay and put the line over the circle. Just put that, and I'll put some stroke. And then make it a white line around the circle. Now, so I want to animate the scale effect. And also animate the opacity. So we need some sort of a trigger here. So I can attach a trigger with on tab gesture here. And if you tap on the circle, then it will be animated. So, so we have animation, but it is not appearing because we haven't added animation modifier here. That's a little animation here. So now I don't want to I don't want the second thing to happen. The expand thing is fine, but the shrink one, I don't want to have it on the screen. So for that, what I can do is one way I can do is like I can put the repeat count and repeat forever, and with auto versus false. So it will be repeating forever, but I don't want to repeat it forever, but I just want to repeat it. I want it to be happen only when I tab on the circle. You can't use this. So here comes the explicit animation. So what we need to do is we just surround this thing with the animation modifier. So this will happen as usual, but we'll have control over here. So what we can do is like we just set the animation to false here, then with the animation. Now what happens when I tap, then this appears. Here's how we can control this particular animation with the with animation function. So this is called explicit. You have more control over when to do what. Mm. It also has a completion handler. So once the animation is completed, then we can trigger another animation or we can trigger another action. So for example, I'll have another state variable here. I'll put 2, and then I'll display some text on the circle. Put 1, 2, 3. Font is dot launch. Some capacity. I need to 0. So this completion code, then we can toggle that. So after the first animation is completed, then this second one will be triggered. The second one will be the opacity animation. So let's see that. Yeah, it is not animating because we are not wrapping this change with animation function. We will have to animate it with that. Now you can see the opacity animation here. So that's how we can chain the animations. With this thing also, we can chain multiple animations as well. So uh, and also, so there is another example here, which can tell so how we can continually apply the explicit animations. Here I have a scorecard. So when I increase the scorecard, then the numbers will be increased. But I want to animate the numbers if it reaches a particular level. Say for example, if it is 5 or 10, the multiplications of 5, then I want to animate. And here's how we can do with animations. So we have a condition here. So if the score reaches the multiplication of 5, then we are triggering the animation here. And there is another code here which sets the animation back to the original location. So we are triggering that thing after 400 milliseconds. So you can see that animation. We can conditionally apply the animations with this explicit animation. Sounds good. Are you all able to follow that? Just quick feedback.
Yeah, good.
All good? Okay, thanks. Okay, so we were talking about the trigger. So this is one trigger that is causing these animations. We can use multiple other triggers as well to the animations. For example, we can use some controls like toggle, and where we can put animate. There we go. Please. Adding it. So this will. So here we have to call the animation function so that toggle happens. It will also animate the change. So you can bind the animation with these controls. It's something they call it as a binding animation, something like that. So we can do with this, and we can also use sliders, steppers, and other controls as well to trigger the animation, and even the gestures. So we can have some drag gesture, and we can trigger animation and have a sample here. So if you see there is a circle in the screen, and when you drag it, you can see the animation. So we have attached drag gesture animation here. So on change, we are doing some updates on the offset, and on end, we are triggering an animation with animation. Now if we just bounce back to the original location, something like that. So here also we can use animation. So during drag also you'll see the some kind of animation. So the animation can be triggered in multiple different ways, multiple different features. Okay. Next up is view transitions. View transitions are nothing but to define how a view should appear or disappear from the screen. When a view appears, then we can have control over how we can make it appear on the screen. For example, see this view transition here, and I'll have my skeleton code, and here animate is like if animate is true, then I want this rectangle to appear. Okay. Then rectangle appears, but there is no animation here. We can attach a transition effect here. Okay. To put, it won't animate because we have to attach animation modifier as well to that, or we have to use explicit animation here. Either way, we can. You can see scales up and scales down. So previously we used to do this animation with modifying this offset or the position or the scale effect, but there are predefined transitions available. When a view appears on the screen, then we can use those transitions. So in previous examples, we saw the shape, the object is already there on the screen, then we are animating that. Now a new object comes up, then we are animating that. So we have multiple different ways to animate this, move from bottom. Okay, like that. I have a sample for this. So probably many of you have seen this on the LinkedIn post. So I have this food related transition effect here. So we have a food emojis here. All these images are here, and I'm just looping that images and displaying it in a text view. And then I'm applying transition. So let me just put this simple transition here. Then I'm attaching an animation modifier to the G stack, and the trigger is here. So I'm changing the current index. So whenever the index is getting changed, then I'm displaying the particular item on the screen. So the previous one will disappear and the new one will appear. So we'll see a nice animation like this. So there will be two transitions here, disappear and appear. Opacity. Multiple different options here. Like if I just click and scale, identity, slide, and so many other things are there. So if you talk about combining animations, like if you want to have different animation for appearance and disappearance, then we can use this asymmetric transition. It's a composite transition which has two things. If I can just put slide, and the removal will be opacity, then you can see that animation. So the disappear happens with the opacity, then the new one happens with the slide animation. So that way we can control this transition effect. And that's about the transition. Let me just check the chat if I have anything. Just the next one is okay. Now we can see some of the ways that we can customize these animations. So first thing is the animation curve. So we have seen the different types of animations like ease in and out and linear and other things and all. So we can customize our own curves. So custom timing curves. So SwiftUI gives us control over how the animation movement should take place. I can just show you a demo. Some timing curve. Let me just so I'll attach animation here. We'll have a bounce animation here. Okay. Offset. So we have this animation. So now you can change the timing curve. So if you put a dot, then you can have this timing curve thing that you can customize. 0.5. There are 4 different values here. With these values, we can customize the curve of the see that animation, then it will be in different manner like that. So even you can create your own animation function that you can use it. For example, you can extend animation class and add your own animation, something like that. Timing curve. Your values here. 0. So you can use this pounds thing here. You can have something like that, and you can, if you want to add a duration, then you can declare it as a function. Function is static box with some duration time interval returns animation. Oh, same thing here. Modify the duration, then we'll have the duration here. So here, a function that will have a duration of 2 seconds. So you can have customization over the animation curves here. And so if you want to know more about this particular, what these 4 values does, then there is a wonderful resource here. So this is a cubic Bezier curve that is called a cubic Bezier curve. So you can have some sort of a customization here, and you can change this curve and it will update the value here. For example, something like that. If you make it, then you have this 4 values. You can copy that and you can use it here. For example, to put 0 here, 0 here, 0 here, 0 here. Let's accept. Yeah, the animation will change accordingly. Yeah. So this cubic Bezier path, it's it's a universal. It's not only related with the SwiftUI, but it's been used in other animation frameworks as well. Next up is about with the transaction. Basically, animations can be triggered in many different ways in many different places. So if you want to control the animation for a particular scenario, then we can use with the transaction. So we can just wrap our state changes under with the transaction function, and then we can modify that particular. We can either disable it, or we can even change the different animation for the particular specific scenario. So the demo. Skeleton. So I'll have some sort of scoreboard here, text. I I will apply some scale effect here. I will touch on animation modifier. Some default animation. Use animate. Now, so I declare score thing here. So, then I'll increase the scope. Pretty. Okay. So if you want to make that, there is a expansion and strength animation for each score update. So now if you want to have some sort of a condition where you want to only animate the odd numbers, how we can do, we already have a animation modifier here, so that will animate whatever the change has been happened with this animate functionality. So here we can use with the transaction. So for that we have to create a transaction object. We can set different values for the transaction object. So we'll pick up this disable animation to we'll run transaction. So what we do is we animate just run this. What will happen? There will not be any animation here. So we completely cut down the animation here, even though we have animation modifier here. So we are controlling the animation with this transaction thing. So we can have some sort of a condition here, like if score is like even number, then apply the animation. So now we have a conditional thing. So half of the things will be animated and other half will not be animated. So here, so odd numbers will be animated, and even numbers will not be animated. So we can have control over the animation, and we can also define animations dynamically. Suppose if you want to make the even number animation with the different animations, then we can just use Put some bouncing thing here, then can put the animation thing here. Here, this will be one type of animation, another next thing will be a different type of animation. You can either disable it and you can either add animation. So if you want to disable the existing animation, you have to use this. If you don't use this, then this will not take place. So you have to disable the existing animation, then you can put a new animation, or you can completely disable animation for certain scenarios. So with the transaction is useful in that particular thing. You can have some advanced customizations with this with the transaction function. Next up is animatable protocol. So this is an interesting one. So this animatable protocol in SwiftUI lets you create custom animations for non-standard properties. See, just by confirming this animatable protocol, we can animate a property that is not directly supported by SwiftUI. For example, if you want to animate your custom shape, SwiftUI doesn't know how to animate that. So we can add custom animations through this animatable protocol. And in older OS versions like iOS 15, 16, many of the properties are not being supported with animations. So there you can use this animatable protocol to add some sort of a support. You will have a full control over the values. So when there is a state change from 0 to 10, then you will receive all those values in between from 0 to 10, and you can do whatever you want to do with that values. So those are called like interpolated values between the state changes. I'll show you a demo, you can understand it better. Here we have that's built-in code. What we can do is we'll have some circle here, series of circles here within GStack. I'll put that circle so that it can appear. Some for each, some range. What I'm going to do is I'm going to animate the z index of this circle. So I have this frame, and I'll apply z index. I think it has to be double. Then I'll put some offset so that we can see all the circles. Similarly, we have for y. So we can see all the circles, but it's all in the same color. We'll put some different color for each of them. Colors. For the color array here. Here. And then orange. I'll repeat it. Yep. So we have all different colors here, and we'll just put colors of all different colors. Now I'm going to have another white circle behind all these circles. So circle. To be a white circle. So we have put some little bit bigger circle. And then G index. I want to animate the G index so that we have this animation thing. So everything is set now. If I run it should animate because G index is a numeric value, so it should animate, but it doesn't animate because G index is not supported by SwiftUI. So what we can do is we can use this animatable protocol to add support to the G index thing. So for that, I'm going to declare a new view modifier, G index modifier, that extends view modifier protocol. So that we have something body to be declared. Yeah. Content. We have some index that I declare it here. We have this view modifier, and we'll create an extension for that modifier to apply it on the view. So we'll create a function like new G index of and some, and here I modify as G index, modifier of index of index. That's it. So now instead of G index, we'll call this new G index. Now when you click, there will not be any animation here because we haven't used animatable protocol, but we're just simulating the G index functionality here. So now we can extend this struct with animatable protocol. We make it conform to the animatable protocol. Once you add the animatable protocol, we'll get access to animatable data, so which we have to define it here. It's double some getters and setters here. So for get, it will return the index, and for set, it will update the index with new value. Okay, now let's see the demo here. Okay, okay, hold on. We have not used the animation modifier here, so probably this animation default. Probably will test it without using. So there is a delay in update, I guess. Okay, so now we can see there is no animation here. So when you add this animatable data, then you can see the animation. I guess, yeah. Now you can see the animation. So what happens is like from 0 to 7, all these values are interpolated through this animatable data variable. So when you add animatable, then automatically SwiftUI push all these value changes to this view and via this animatable data. And once the animatable data is updated, then automatically the body will be updated. That will be re-rendered. So that's how we can see this. Suppose if you want to check that, you can just put some this thing here. Put print value. If you run it, you will see the values from 0 to 7 here. See, all these values are interpolated from SwiftUI. If you use this animatable protocol, then yeah, you'll get all these values and you can do whatever you want to do. So once these values are updated, then SwiftUI automatically re-renders this whatever there in the body. That's why we are seeing this as an animation. See it as an animation here. That's the concept behind animatable protocol. Let me just see if there is anything. I have another sample here. Maybe okay, you have seen this sample on the LinkedIn post. So we have a custom shape here. Custom shape is nothing but we just play around with this path object and we'll form some sort of a shape. Like we can move around the points and we can add arc and we can add lines and we can form our custom shape. So these custom shapes, SwiftUI is not aware about how to animate this custom shape. So we can use this animatable protocol and we have these interpolated values in particular variable. Then we can use that in certain places to animate it. So here, if you see this slice, we are animating it up here and also with button click. So what we are doing is we are setting this end angle as 0. When the button is clicked, then end angle will be set as 0. Then it is set to 360. Between 0 to 360, all these values will be interpolated through this animatable data. So this animatable data is setting that value to end angle. So once the end angle is set, then this path will be re-rendered every time. So that's why we see a nice little animation here. So that's how we can add animations to our custom shape or unsupported properties in that. That's about it. And now we'll see some more animation techniques. The first one is with the matched geometric effect. So it's a kind of a modifier to specify two different views to be considered as a single view, so that we can do some animations with that. So here we will have two different objects on the screen, and during the animations we transform one object to another by using this matched geometry effect. Let me show it in the demo. By the way, all this code is available in GitHub. I will just upload them and you can see it after the session. Okay. So we have this thing here. We have a skeleton code here. So what I want to do is I want to switch between two objects. So we have two objects. I'll set the we have to move this spacer here. I'll set the offset for this particular thing. Set is x. So we have two objects here, like with the animate flag we are displaying on specific board. Then there is a two different rounded rectangles here. So if you want to animate that, then with the animation, we can see the animation, but it's an opacity based animation. One object is not converted as another object here. So we have two different animations here. So if you want to convert that into a single one, so if you have to consider that as a single object, then we can just add matched animation geometry effect, and we have to put an ID and some namespace you have to declare. So namespace is nothing but a kind of a container that will represent these two views within it. Space where same thing. I can apply it here. Okay. Now let's see. See that? So one object is moving towards another object. It's being converted as another object. So that's the power of matched geometry effect. You would have seen this animation in many apps, like there will be some sort of a list. There will be a product displayed on the list, and when you click on that product, then that product will be enlarged as a big one. So that is being done with this matched geometric effect. You can even change the width. It will automatically animate that width. So that's about matched geometry effect. I have a sample for that. You would have seen that sample in the LinkedIn post. So this is about the tab bar. So what I have is I have three different tabs, and I'm looping that and rendering it as a button there with some background with rounded rectangle. So this rounded rectangle is being attached with this matched geometric effect, so that this when you click on the search, then this can move there. Suppose if you won't use that, then the default animation will be like that. Fades out and the new one will comes up. But if you change this geometry effect, then it will move towards the next one. And this there will be some issues with this match geometry effect running on the canvas, like it won't work sometimes, but it will work on simulators and the real devices. Here there is some glitch there, so it won't run smoothly. So you can just run it on the simulator. At the moment I'm not opening the simulator because it will take some time, so, but it will work fine with the simulator. Okay, next up, animating a custom shape. Okay, so I'll have skeleton code. We'll put a circle. I'll do some animation with the trim modifier. So just building up the circle with some stroke. Line with us 3. That's an overlay here. And the same circle here with a different color. So we have overlay of a red circle here. So if you apply some trim animation, trim effect here. So trim is nothing but you can trim the particular shape with the from and to values. From I put 0.1 to 0.3. So you can see that. So it only displays that it trimmed from 1 to 3, and it's just showing that thing. So I'm just going to animate that with some angle. Maybe I'll declare some angle here. We don't state CG float. Similarly, we have the end angle CG float with this. Some animation with animation. some limit here for the duration of 1.5 seconds, and I'll also attach repeat forever with auto reverse. Start will be 1.0 and end will be 1. The start and end thing here. What we are doing is we are just changing the value of the angle, so that and it will repeat forever, so that you can see a nice animation like this. Yeah, so that is a kind of a nice animation, and you can apply this particular animation with your custom shape. I have a shape thing here which looks like a hot beat, so let me pull that hot beat shape here. So that's a custom shape here. I just played around with the path object and added some lines and things like that. So it will look like a heartbeat animation, heartbeat shape. So I'll replace that with heartbeat shape. Similarly with circle, and I'll have some 200 and 200 things like that to make it big. Now the same animation happens on the custom shape like that. Yeah. I'll see this animation. So you can make any type of animations with you can make any type of custom shapes, and you can animate it with this, and there are multiple other properties that you can use. We can use animatable protocol. With that you can animate these shape changes. So it's one thing to know. And stuff is about animation with masking. So masking is about, so I have a demo here for the thing. So masking is nothing but you'll draw some shape, and you'll mask that shape with another shape. So basically you just mask one thing, and underneath it will show another shape. So for example, let me just animate this particular thing here. Let me just run this. So we have an image here, a Steve Jobs image, and on top of that I have put some rounded rectangle with the stroke, and also I have just masked some things here. And if you can just see that, you can see that little animation here with glowing edges. So how this is done is, like, if you just remove this mask, you can just see I have this rounded rectangle, so this appears here, and I have a foreground style with some linear gradient here. With that, I'm just rotating. I'm just applying the rotating animation here. So what happens? It will rotate over the image, and that rotation, we are just applying this mask. This mask is nothing but the size of the image. Another rounded rectangle with the size of the image, so that it will mask the underneath rectangle. And you can see this nice little animation. So this is another technique that we can use with the masking. Then about face animator. And the face animator is kind of a modifier that allows you to attach a series of faces to a view, and you can alter the view on each face. So for the demo here, we have a demo here. So if you see the face animator here, you can see you can attach the face animation to any view. So you are attaching the face animator, and you have to define the faces here, and there should be some trigger here. If you don't put the trigger, then it will be animating forever. So you have some trigger here, and that will give you the content of this main content and these phases. So on each phase, how we can modify this content is up to us. Like here with the foreground style, with if the phase is 1, then I'm making it in blue. If phase is 2, then it is red and green. So for each phase, I'm changing the color here. Similarly for the scaled effect, if you just animate that, you can see there's 1, 2, and 3 phases here. 1, 2, 3. So you can have multiple different phases and multiple different modifiers here based on the phases. And also you can change the animation for each phase. Here we'll have a phase thing, and you can apply, you can put a switch statement here, and you can apply different animation for each phase. So that's another thing to know on phase animator. This has been introduced in iOS 17. It's pretty new, but it's very powerful, and we can do many things with this phase animator. Okay, here comes another ultimate thing about adding animations to your app. So far we have seen all about SwiftUI related animations. This one is a little different. So this is by using the Lottie files, we can add animations to our app. So Lottie files. So if you go to this lottifiles.com, then you can see many different animations. There are premium animations and there are free animations here. You can use them in your app. So this is being defined with some JSON data. With the JSON, these animations happen. So this has been developed by Airbnb. So they have released some SDKs for iOS. What you need to do is you just need to get this GitHub repo and go to your Xcode package dependencies, and just need to add that thing. Copy that. Paste it, then you'll get this Lottie animation. This SDK, you just need to add this SDK to your project. I have already added it. So it comes like this. Once you have that SDK in place, then you can grab some of these animations. You can just go here and here, and you can just download it and you can save it locally. And there are multiple different formats available. .lottie is a compressed format, and we can use .lottie. It's the latest format that has been used, and we have this traditional JSON format thing. So you can download this JSON things, and it will appear something like that. So I have a few different things here. Take landscape. It's a JSON data with so many numbers and things like that. So these are the input for that animation. With this, that Lottie framework will animate the change, animate the file. So let me show the demo here. Here it is. So what you need to do is you need to import this Lottie framework, and then we just need to use the Lottie view, and it has some parameters, like we have to specify which thing you want to animate here. So whatever you download, that you have to put it here. Then you have some playback mode and the progress and loop, other things. You can play once and you can play forever, something like that. So once you put that, then just see that animation in your app. So all these complex animations, you can just add it in your app just like that. If you want to switch, then you can just switch with other landscape. And then run it. Have these animations. You can add these animations in your app instantly. And that's about it. And yeah, so we have come to the best practices. So what are the kind of best practices that we can follow while adding animations to your app? So first thing is keep animations meaningful, like have a clear purpose for that animations. Like if you want to provide a visual feedback to the users, or if you want to guide your users' focus on the changes on the state, or if you want to improve the navigations, you just need to have a clear purpose for that animations. And you need to avoid overusing the animations, because excessive use will be distracting for the users. It may lead to performance issues as well. And then you'll have to test across devices. Animations might look different on older devices. You make sure you test those animations in all the devices. And the chaining animations, you can use it whenever needed for the complexity. And then respect users accessibility settings. That's a very important point. So users have a setting in their mobile, like under accessibility, they can set to reduce motion. That means they don't want to see many animations on their app. So we have to respect that. We have to check before triggering any animations. We have to check whether that particular motion, reduce motion, is set. If it is set, then we should avoid, or we should minimize the animations. For example, I have a small sample here. I think here it is. So if you see that, so I have this modifier. So this is nothing but the animation modifier here. So I have created a different view modifier out of it, where I'm just checking whether the user has enabled this reduce motion setting. If it is enabled, then I'm not attaching the animation modifier. If it is not set, then I can add the animation thing. So this particular modifier, you can use it. So I have a view extension here. So motion animation, you can use it in our app, so that it will automatically be detecting the setting, and it will cut down the animation. So we should practice checking this reduce motion enabled thing. And another thing is debugging the animation. Suppose if you want to debug the animations, what you can do is you can just apply a setting in the simulator under the debug menu, where you can mark slow animation, so that so the animation will run in a slow phased manner, so that you can just debug and you can check things. Also, you can use the preview to view it in a different devices with the different layouts. That also you can do. And whenever possible, you can reduce the animation duration, because short and simple animations are good. And minimize the state updates, and so you need to avoid triggering the animations with the frequent state changes. So that will be distracting for the users. And also you need to be very cautious about the repeat forever, because that will repeat forever. There is no other functionality to stop that, so you need to be aware about that thing. And also the on appear, and if you make an animation, if you trigger an animation on appear, then that particular view may re-render multiple times, so you just need to be aware about that as well. And for high GPU demanding animations, we can use Metal APIs. Metal API is a different framework which is being used for game development and high graphics rendering thing. So you can use that for high demanding animations in the app. So for example, here there is a difference with metal and without metal. You can just run it. And this left side, I don't know whether you can see the difference in the online share session, but the left side is very smooth, and the right side is a little laggy. So metal is best. It uses the GPU performance to give a better animation. And here are some of the resources that you can go through and expand your knowledge on the animation. So first thing is WWDC videos. You can just go to WWDC and search for animations, and so all the latest updates you can find it there. The next resource is Big Mountain Studio. It has got a wonderful book called SwiftUI Animations Mastery, which explains each and every option, each and every feature in a detailed manner. I would highly recommend to check that out. And another one is if you want in-depth videos on animations or what happens behind the scene of the animation, you can check out objc.io Swift Talks. It's a subscription-based platform, so you can check it out. Then we have another book called Pro Swift UI by Paul Hudson, who has a separate chapter for Swift UI animations. You can check out that as well. And there are a couple of YouTube channels like Hacking with Swift. It's again from Paul Hudson, and Swiftful Thinking is from Nick. So where you can go and search for animation, they have a very good playlist for animation videos. You can check that out. And there are a couple of Patreon accounts. I found them very useful, and they have many animations put out there. The Sukode and Subham Singh. You may check their Patreon accounts as well. So now, overall summary. I'll just go through what we have seen in this session. First, we saw the introduction to the animations and how SwiftUI animations are behaving and all. Then we saw the implicit animations where we explored various animation options, animation curves and all. Then we controlled the animation with the explicit animations, and we moved on to the view transitions. Control how the view should appear or disappear on the screen. After that, we customized some of the animation curves. We created our own animation curves, and with the transaction, we disabled the animations. And with the animatable protocol, we added animations to unsupported properties and also to some shapes, custom shapes. Then with advanced animation techniques, we saw how we can animate with custom shapes and how we can use masks and match geometry effect and face limiter and all. And finally, we saw some best practices and resources to improve knowledge. So that's the overall summary of the session. Yeah, that's it for the today's session. So all this code that we have seen here that will be available on this GitHub. I will just commit that now. I'll just commit it. Just commit it now itself. Okay. So, just proceed. So stage on. So you will get that in your thing. So if you go to this folder, Selvarajan, we can see the repository here. So so you will have all these examples here. You'll have that samples and whatever we worked on in this session. So all these things will be available here, and also you can see the presentation is a PDF format onto this location. Okay.
Really good insights.
Yeah.
So thank you so much, and thank you so much everyone for joining this today's event and make this possible.
Yeah, thank you. Thank you for yours.
Thank you.
Thank you, sir. Thank you for arranging this beautiful session and taking the session.
So I request everyone to start camera and we can just take a one small picture.